Thank you. Thanks, Barb. Hi, everybody. I am Terry Ryan. I work here at the Napa Valley Unified School District. I'm the elementary, we call it K-5, math academic specialist. And I work with the teachers of your kids and the principals and the vice principals and anyone else out there who has questions about math. And I just want to let you know, I actually came from the high school realm. I taught high school math for 12 years. And this was a real change for me, and I am enjoying myself immensely. Just learning how kids learn and watching them grow and become very excited about math. We are in a very exciting time here with our new math adoption. You guys may not be feeling it right now, and I know that some of our teachers aren't feeling it right now, but when you watch those kids in action in the classroom, you can't help but get a smile on your face because kids are excited about math. They don't want to stop math time. They don't even want to go to recess sometimes if we haven't finished math. And it's very exciting. So I am so glad you guys are here tonight. Now, first I want to just go over, I have a little agenda here, but it is very changeable if this is not what you guys need. So I want to tell you what I thought, and then you tell me if that's what you would like to have happen, okay? So the first thing I was going to do is I have two lessons with me. I have a first grade lesson and I have a fourth grade lesson from our new curriculum. And what I was going to do was walk through some of that with you as if you were the students and I was the teacher, so that you could see what your kids are doing in class. And then after that, what I thought we would do is look at a possible homework page that might come home, or some of the individual work that your kids do. And then what I wanted to do was talk to you a little bit about what you can do at home to help your kids, what may not be very helpful to your kids, and just some other things like that that may be questions that you have. I also want to answer questions that you might have. So how does that sound? Sound like fun? Okay, there's a lot more of you than I anticipated, so I think if you're here as couples, if you maybe work together on a page, we might be able to get pages out to everybody. I do have it in both English and Spanish, so if you need the Spanish, go ahead and take it so you can see what your kids are doing. We'll start with the first grade lesson, okay? Now for first grade, we're not going to start with any pages, we're just going to start by talking. This lesson is something that they're doing in the second unit. Your kids may or may not have gotten to this yet if they're in first grade, but they will be soon, okay? So I'm going to start just by asking everybody in the class to think about what this is. Just think about it. Don't say anything. Don't show me. Just think for a minute. And think about what this looks like to you when you see this. Okay. Now, I have a card here that I want to show you. Okay. And again, I want you to think about when I show this card to you, what this means to you and what else comes to your mind. Okay. How many have a thought about this? Okay. Who wants to share what they're thinking right now? Don't be shy. We love hearing what people are thinking. Hi. I'm hearing this as a number 4 on a die. Is that what how many of you are thinking that? This looks like a number 4 on a die. All right, somebody else? Dominoes. I'm hearing dominoes. How many are thinking dominoes? Yeah. Anybody else thinking something different? 4 circles I'm hearing up here. 4 circles. 2 plus 2 over here. So somebody's going automatically to some sort of an equation or expression. They're thinking about how they would show this. Does anybody have an idea what they think might be under this other side based on what I showed you a minute ago?
2 more circles.
Oh, I hear somebody saying they think there might be 2 more circles under this side. Does anybody else think there might be 2 more circles under this side? Does anybody think there might be something different than 2 more circles under this side? Might be 4. Can you tell me why you think there might be 4 circles?
The width of that side is the same as the width of the
Did you hear that? She said the width of this side is the same as the width of this side. Okay? Any other thoughts about that? It might be 0. And why do you think it might be 0? Because she doesn't see anything there right now. Exactly. And there's always one in the class that thinks that too, by the way. You bet. Any other thoughts about that? It might be 3. Why do you think it might be 3? Oh, okay. So on a dice, there's 6 and 1, and 1 might be bounce out. Is that what you said? Balance. Okay, so he's thinking they might add up to 7. So that would balance it. Everybody ready to see what's on under the other side of my paper? How many are surprised? I've got one surprised person under here. You really thought it would be 3?
No, the diagonal of it surprised me.
Oh. Okay, she's saying what's surprising her is that these dots are in a diagonal and that they're not filled in, that they're just the outline of the dots. Any other thoughts about that? Oh, so tell me about that. I am hearing somebody say out here that I can show 4 plus 2 with this. Does everybody see that? I have 4 here, and I have 2 here. What does 4 plus 2 look like when I write it down? Oh, let me get another paper here. So I have 4, and I have 2. So I'm hearing put a plus sign in between them. What does that mean?
Add them together.
Add them together. What do you mean when you say add them together? What are you thinking?
Put them together.
Okay, so if I have a pile of 4, and if I have a pile of 2, and I smush them all together in the same pile, does that make sense to everybody? And what happens when I do that? What does this become? This becomes 6, okay? And the way that I show that 4 plus 2 and 6 have the same value is to put an equal sign in between them. Okay, I'm going to go out of teacher mode there for a minute. The reason we have these conversations is because before we've always thrown the equation up and told them this is the way we say it, right? The conversation allows them to actually mull over the information, to hear how other kids are thinking about the math, and to make sense of all the symbols and what that actually means. This one right here, this symbol, is one of the biggest confusions to kids at all levels of math. They really do not have an understanding of what an equal sign means. A lot of them, if you ask them, what does it mean to put an equal sign up there, they'll say, it means you're going to get an answer. And that's their understanding. They have no concept of the balancing of 2 sides of an equation and what it means for one thing to have the same value as the other side. Okay, so what you're going to be hearing and seeing from your kids is a lot more talking about what they're seeing and talking about what they're thinking. And they may want to tell you that when they come home. Look, this is what I'm doing, and this is why I'm doing it, and this is what we talked about today in class. And the best thing you can do is just let them share it with you and let them tell you what they're thinking. Even if you don't understand what they're saying right now, that's okay. Just nod and thank them for sharing their thoughts with you. Okay? So then we might go on and think about a different way that we can show it. And I might show them this. And that ask them, if we're still looking at 6, what do you think is under the other side of my card? And then I'm going to take a temperature around the room and see what kids are thinking. Because some kids are going to think there's something under that side of the card. They just do. They're still not quite getting that we're talking about putting the 2 sides together to equal 6. So we're going to have quite a few conversations about that. Okay? What do you think might be under the other side of my card? I see this up here. Somebody did this. I would hope to see that, right? I might ask them, show me. Show me what you think is under this side of the card. Some kids will do that, right? Some kids will do this. It's kind of hard to, okay? Which is also good because they are conceptualizing and understanding that if I put 2 and 3 together, I do have the same amount as what I hope is under this side of my card, right? And those are all really good signs that kids are understanding and making sense of numbers and how they relate to each other. So after we have a discussion about this and see our different numbers and talk about why the other number's the same, I might say, if I have 6 and I take this away, what will I have left? And start doing some number family talks with them. We call them fact families or number families in conversations so that they understand that the addition and the subtraction goes together and that they do have a relationship with each other. Okay? Kids actually love to talk about what they're thinking. So this has been very exciting for them. Instead of me just saying, figure out what this is, we're having a discussion about it and they get to say how they think about it and they get to look at it in a different way than they've been told before was the right way to do math. And it's very fun. So let's try some homework now. So this is what we might see. Now I'm going to just kind of split these and send them out. These are English, and I'm also going to send some Spanish around the room. So whatever, and maybe one for every couple of people so everybody gets a chance to see it. Okay? And then just take them and pass them on. So I want you to just take a minute, look at it, and there's 2 things I want you to think about. Okay? What do you notice? And what do you wonder? What do you notice? And what do you wonder? Okay? Just to yourself now. Just looking at it, thinking about it. Just you and the paper. All right. Who has a I notice that they'd like to share with us? Yes?
A relatively easy equation that turned into 5 equations.
I'm hearing back here that a relatively easy equation has been turned into 5 equations. Okay? And I'm wondering if that is frustrating him or if he's just wondering why we're doing that. A little bit of both. Okay. Okay, so what I'm hearing is, why are we doing all this extra work and doing all this adding here and this adding here just to get to here? When I know that 5 plus 5 is 10. Okay? That's a good question. Thank you. Any other I notices?
So when you add them horizontally and then up and down, you get different answers, but when you combine them, you're getting the same. So like 5 and 5 is 10 and 4 and 6 is 10. So it can demonstrate to the student that if you add it differently, you have 5 and 5, you get 10, you have 4 and 6, you get 10. So you have different possibilities with different numbers, and you still can get the same answer.
Okay, so what I'm hearing up here is somebody saying that what they're seeing is that we can do this and get 5 plus 5 is 10, and we can do this and get 4 plus 6 is 10, and we can see that there's two different ways to make 10. Okay, so it allows students to see that there's more than one way to make 10. Or 5, or 4, or 6. Any other notices? How about another I wonder?
I noticed that it's like a puzzle.
She notices it's like a puzzle. So something fun maybe to work on. So I'm not just being told, here's an equation for you. What's 4 plus 6? Give me the answer. What's 5 plus 5? Give me the answer. What's 2 plus 3? Give me the answer. Right? What's 3 plus 1? Give me the answer. But it's been put together in a way that looks kind of fun and enticing to a kid. Another thing that I notice, oh yeah? Yeah.
Well, each one sort of gets harder too, because you could easily just count the dots to get your answer. Then when you have to go the other route, you have to actually dots.
Okay, did you hear that? It's getting a little bit harder as we move down the page, because you can easily count the dots, but there are also some other ways to look at it and start making sense of it. So as we start looking at some of these other problems, and let's all look at this one right here. This is the next one down, number 1 on the left side there. How many of you can look at this top row here and know exactly how many numbers you have without counting? How many of you needed to count them to be sure you knew how many you had? Okay, now in a class of first graders, I'm going to see a real mix there. And I'm also going to hear something like, I knew this one was 5. And I'm going to ask them, how did you know that was 5? Because that's the way we set up 5 on a dice. So I know that's 5. Awesome. Okay, that's what we call subitizing, when they can see things and know immediately what they are. They're internalizing those things and understanding them. So now they're looking at this. 5 plus 2 is 7, and they're going to put 7 in here, right? And also, we've got a different way to make 7 here. And this one, I will tell you, takes them a minute to figure out, the 4 and the 3. They're not seeing that one nearly as quickly as they are the 5 and the 2. But once they do, they will remember that, and all of a sudden, 5 and 2 and 4 and 3 are the same thing. And I can put them on opposite sides of an equal sign, and that makes sense. Because they have the same value, and now I understand that. That's the part we have tended to skip. We have told them 3 plus 4 is 7. We have told them 5 plus 5 is 10. And we have expected them to memorize that, but there has been a real lack of understanding of why or how. And what happens is kids will do very, very well for a certain amount of time, and then all of a sudden, when the numbers get hard or the ideas get hard, they hit a wall. And they don't have any conceptual understanding to back up on and make sense out of something now that they're struggling with. And so what we're trying to do is, from the very foundation of their time starting to work with numbers, we are giving them the opportunity to build that conceptual understanding from the start, so that when they get to the big numbers or the hard concepts, they have something that they can fall back on to make sense of it. That's what's so important. And that's why you'll see your kids doing great until they hit Algebra 2. And all of a sudden in Algebra 2 they're struggling and we don't understand. My kid has always been so good at math. Why is Algebra 2 so hard? That darn teacher doesn't know how to teach math. What's the matter with them? If they would just teach it the right way, my kid could do it. Well, the problem is your kid is not being taught the math the way that they understand the math. And this is allowing them to build those concepts and build that understanding and build a foundation of how they understand numbers and how they understand those relationships, so that when they hit those Algebra 2 crazy logarithms, they can start making sense of them. They can build on that.
Would you agree that kids that are in 4th grade now that have not been taught this way at all are struggling because they just learned to memorize, never really understood the whys and the wheres, and now they're struggling?
Yes. I'm hearing up here that she's asking me if the reason that our 4th graders are struggling right now is because they've never been given this opportunity to look at numbers this way, and now they're starting to look at numbers this way, and they're struggling because they don't have that foundation built where they have been building that understanding over the years. And yes, 3rd, 4th, and 5th grades right now are struggling the most. But I will tell you that I have been in and out of our classrooms over the last 6 weeks because I have been trying to get out there to support, help, and what I am seeing is that 3rd graders are already closing the gap. Our 3rd grade students came in with a gap like this on bridges, and just in the 6 to 8 weeks that we have been in class, their gaps are closing, their understanding is increasing, they are getting faster at manipulating numbers and understanding what's going on, and they are excited about what they're doing for the first time. It is thrilling to see. I really believe in what we're doing here. I've taught this way all my life. Well, all my life in the classroom. And it's been hard for kids because they have come in with those gaps. And I was doing it in high school. And we spent a lot of time trying to close those gaps. But I believe in it because I've seen kids become very confident about what they're doing and what they know. And I'm seeing that in our elementary classrooms right now.
So is it something that kind of existed in the upper grades but not in the lower grades, or?
No, this is how Common Core has come about, because Common Core is a rewriting of our math standards. Before Common Core, states had their own set of standards and their own way of looking at math. And what happened was we were seeing such discrepancies across the United States about how kids could do math and how kids could understand math, that a bunch of really smart guys from our colleges and from our high schools got together and said, we've got to do something to standardize what's being taught and how it's being taught across the United States. These other countries are killing us. Their kids are knocking it out of the park. They understand much deeper mathematics at much younger ages. And our kids just keep falling more and more behind. So what they did was they looked at the kids in Singapore and they looked at the kids in Japan and they looked at these kids who were scoring high and said, what is it that's going on in those classrooms that's making them so successful? And they sat down and they wrote the Common Core math standards based on what they were seeing in those classrooms. Question?
Well, I think that I agree with you on what you just said. I think that it's more than just the classroom, though. I'm on board with the Common Core, and I have to be on board with it, right? So I'm ready to be just like full force buy into this, okay? Because I need to help my children. Now, Singapore and Japan were basing our standardized testing on their scores and how they do it. It's not just the classroom; it's the parents. It's the involvement in that. The educational culture of it's just different than
Yeah.
even East Coast to West Coast. I mean,
Absolutely.
we want our kids to be happy and loving, and East Coast is more like education.
Yeah. No. And that was an oversimplification because I was being asked about the Common Core standards. Right, yes, we all know that there are many, many other reasons that kids do well or don't do well, right? But starting with a common foundation is a really strong place to start. If all of our kids are getting the same thing and being taught to understand things in the same ways and being given opportunities to see things in a way that makes sense to them, we are building a much stronger foundation for them and giving them the opportunity to grow at a much better rate. I see 1, 2. Okay, thank you. Oh, thank you.
My daughter happens to be in first grade, and I'm seeing her come home with sheets of addition that don't have these dots. So, is it coming later, or why is she not getting building blocks? She's just getting worksheets.
She's actually getting them in class. The question is, why is my daughter coming home with worksheets that look kind of the old way, where they're just equations rather than some of this? There are 2 reasons for that. One is that because parents were struggling and teachers were struggling with how to help parents help their kids with homework, that one of the things they thought was, until we all get a little more grounded in this, we'll make the homework something that is accessible to all, and we will keep this stuff in the classroom while we all work on getting better at doing it and understanding it better.
So is the homework not coming from Bridges?
Some of it is coming from Bridges and some of it is not. Some of it is like the old board math and things that have been going on in the classroom for a long time.
What is
Bridges
Bridges?
is the name of the new curriculum that has been adopted in the elementary schools. Okay, it is written by a company or published by a company called the Math Learning Center. I'm going to give you some more information on that in a little bit too.
Is the math experience the same in each grade room, class level in Maps and Unified?
The question is the math experience the same in every classroom at every grade level? And I would say no, not yet. But we are working very hard at that. We are doing monthly time with the teachers, letting them get together and talk to each other about what they're doing. 2 of our schools have been using this program in the classroom for 2 years, and those teachers have been reaching out to the other teachers and sharing some of the things that they've learned over the last 2 years about teaching it, how they organize it, how they talk about it, how they facilitate it. So we're getting there. It won't be the same everywhere for a little while because we're going to have to really work at this and get together and talk about it. But we are doing that. So the question is, has Bridges been adopted in all schools? And yes, this year, Bridges has been adopted in all schools across the district. Last year and the year before, Mount George and Bel Air were using Bridges. They had decided on their own as charter schools that that's what they wanted to do. And so they went out on their own and started using Bridges. It was largely because of what we saw in their classrooms and what we saw their kids doing on standardized testing that helped encourage the math committee that was working on looking at curriculums to take a strong look at Bridges, because both of those schools, the kids that have been using Bridges are scoring better on our benchmark CST. Well, it's not CST anymore, it's the CASP, but the one we took last year, those two schools scored better than any of our other schools, and they have been using this math. That was one of the things that we saw. Also, that their kids had a better understanding of math in general and numbers and number sense. So that was one thing that we did look at. We looked at many things. Everything that we're doing right now has its foundation on the Common Core standards. So we should not be seeing new ways of teaching as they move up. We should be seeing new levels of understanding as they move up.
I'm seeing a lot of teachers who are lost with this stuff. I did that at every single level so far. So
Yeah. Anytime you implement something new, people are lost for a little while. And it doesn't matter what it is. Okay, so I'm hearing three things up here. One, that if the homework looked like what they were doing in class, it would be much easier for the kids. Two, if somebody would write a cookbook-style list of instructions for parents on how to do this, then the parents could do this at home, and that would make parents much happier about what they were doing. Did I capture that right? Okay. That's true. And that's what we've been doing forever. You're right. Here's the thing. Here's the thing, and I know this is hard. I really do understand and know this is hard. And I know that a lot of you are sitting here with kids who are in that Excel phase. And a lot of you are sitting here with those kids who are in that struggle phase. We have them all out there. What we are trying to do is take all of our kids, all of those wonderful, warm little bodies, and get them all in the place where they're in learn phase. That's what we're working on. And we can't do it by continuing to do the same thing we've been doing, because what we've been doing is we have been pushing our Excel kids to keep excelling. We have been pushing our struggle kids to keep struggling, and the gap is getting wider and wider and wider. Something's got to change. If nothing changes, nothing changes. What I did is exactly what they're doing in the classroom. That's the instructions. So if you get something home that you are not sure how to tell them how to do, hooray! Sit down together and go, wow, what do you see here? What does this look like to you? To me, it looks like a bunch of dots. But I do see 2 dots here and I do see 3 dots here. And I know that when I put those 2 and 3 dots together, I get 5. What do you see? And then listen and let them tell you what they see. That's how you help your kids with homework now. And that's why we're trying not to send too much of it home right now, because that's a huge change, right? But more and more of it is going to come home. And we're not going to write cookbook instructions for it, because that's not the way kids are going to learn it. And we got to stop doing that, because that's how we've kept our kids struggling for so long. I get what he's saying, but do you understand that? You know, I have teachers coming to me right now saying, whoa, I understand math that I have not understood ever, and I've been teaching it for 10 years. The parents who do not have higher education, the parents who do not have time to sit down and spend a lot of time having conversations with their kids, those are the ones that keep struggling. Which is why it's so important that we're doing something in the classroom that helps them to get that same understanding that other kids have. And why it's so important for them to have the opportunity to see math in different ways so that they can come into it from a place where they understand it and they can get a hold of it and start making sense of it. So for right now, I would like to switch back and show you this 4th grade lesson so you can see what kind of happens as they move along here. Okay, so I have a question up here. How much math homework should kids be bringing home? In this program, there is usually anywhere between 2 and 3 days a week of homework. It is not every single day. So. Oh, you mean when they do bring it home? Yeah, if you have tried to walk through it with them and they are becoming frustrated and all that, I would stop. I would stop, write a note and send it back with the homework, or email the teacher and just say, we worked on this for 30 minutes. It became very frustrating, so we stopped. And the teacher will pick it back up in the class. That's what they're doing. Yeah. Okay, does everybody have something in front of them? Okay, now this is a 4th grade lesson, so we're zipping ahead now here 3 years. So our kids have been adding and subtracting in many different ways. They have been starting to look at multiplication and may have started talking a little bit about division, but not in the algorithmic way that you're thinking about, that you learned it the first time you saw it. They have been talking about what it means to have many groups of the same number of objects, because the first thing that they're learning is that repeated addition is multiplication. And so one of the ways that they can make sense of multiplication is to build equal groups and see how many groups they have of that number of objects, and they start to put together the multiplication idea. Okay? And then after they understand that, we start talking about different ways that they can look at things to figure out multiplication using things that they understand and know. All right. So this is what we have. We are trying to figure out what rule, and I think it's Riley here, Riley is using to create his table of numbers. This is all we're seeing of Riley's table, because I'm thinking that Raymond and he started goofing off back there and the paper got ripped and some of it got lost, and this is all we've got now. So this is what we've got to work with. And we want to help Riley build his table. So my first 2 questions again are, what do you notice and what do you wonder? And you're doing a thinking thing on your own. What do you notice? What do you wonder? So who has a notice that they'd like to share? The numbers in the left column are in sequential order. Interesting. Who else noticed something? By what? By 12. So the numbers on the left are increasing by 1. The numbers on the right are increasing by 22. 22. Anybody else? Who has a wonder? Is there a relationship between the left column and the right column? That's a really good wonder too. Interesting. Does anybody have a thought about any of our wonders? Does anybody see a possible relationship between the left and the right column? Multiples of 22. So when you say multiples of 22, can you tell me what you're thinking?
The next number in the sequence will be 12, and then the next number on the other column will be 264.
Okay. So we have got a prediction that These would be the next numbers on the piece that's missing below. And I would use words like prediction and all that, and kids are becoming familiar with that vocabulary. I'll even ask them, what's your prediction? And they'll tell me. Other thoughts? Because predictions are what we do in math and science. We make a prediction and then we test that prediction and see if it's true. And that's the scientific method, and mathematicians also use that in building their thoughts and their ideas.
When you divide the smaller number into the larger, each one comes up.
Oh, so when I divide, and it would be this way, right? 198 divided by 9, not 9 divided by 198, okay? I get 22. Oh, and the same here. Again, we're dividing this way. I get 22. Ah, look at this. She's on a roll. So, are we seeing a pattern? We are seeing a pattern. And what does it appear that Riley did to set up his table? Multiplied everything by 22. So Riley set up his table by making the right column a multiple of 22 of his left column. Okay? What I'm just doing there is rephrasing a little bit what the kids said. Sometimes that helps other kids who may not have completely understood what a kid said to sort of be able to go, oh, okay, that's what they're saying. And then we've brought another kid in to the conversation. Okay? So then the next part of this sheet would be, I'm sorry.
I was just going to say, that the key word up there is ratio. And if a parent approaching this page doesn't know what ratio is, and ratio is basically relationship. So if they know that what ratio is, they can help their child figure it out. But if they don't, and ratio might be something in the dark recesses of their childhood math, that
That's
they
right.
remember, then they are kind of up a creek, as far as helping their child.
Either that or they are learning with their child, which is just as good.
Well, it could be.
Just as good. We don't have to, that's the point. We don't have to tell our kids, oh, guys, this is a ratio. Let me show you how this is working. We have just taken the learning away from them.
If they get the ratio, they know if the teacher's taught what a ratio is, and the child can go home and say, well, ratio is a relationship.
Did I say the word ratio until somebody else in the classroom said it?
But the page
I may not. Well, then I'm expecting a kid maybe to see that, or maybe we're going to have a whole conversation before we get there, right? How many kids read directions?
well, I'm just saying that in the classroom,
Thank you. Yeah, exactly.
I'm saying in the classroom,
Yeah.
hopefully the teacher has thoroughly taught the concept of ratio so that when they go home, they know what ratio is.
Okay, see, and this is what I'm trying to say without angering people is no, we're not. We're having a conversation in the classroom, and we are helping kids to discover the idea of ratio. Because if I continue to say, kids, this is a ratio, here's how it works, these are the numbers you use, go home and do one now, they're going to go home and go, what the heck just happened here? But if we have this conversation and it is developed that this is what's happening and this is how the numbers are going, and oh, I see a pattern, and then somebody says, oh, it says ratio up here, does that have anything to do with this? Now we start naming it as a ratio. Now 3/4 of my kids understand. That's right. But I wouldn't send this home for you guys to do. This is an in-class thing. I wouldn't send this home. We're doing in-class right now.
We're doing in class, I get that.
Yeah.
So, but we get sent home this. So what I have done as a parent, I make sure that I get a book, the math book, so that I know what a ratio is.
Yeah.
Because I don't remember what a ratio is. I had to prove my work over here. So they don't need to know that because they're being taught this way. But me as a parent, I need to know what a ratio is first, and then I have to learn it with them their way, this Common Core way.
Yeah.
Because this is the way it is, and so if I don't know it, my kids are going to be lost. So that's why we're here, right? Just to learn how-
It is. And another thing is too, as she was saying here, a lot of parents may have learned ratio back, but how many of them would remember if I sent them all an email and said, by the way, your kid's homework is ratio today, help them out, thanks. How many parents would be going, what? Right? Because, thank you, yes, look it up on Google. So what are we doing? That's right. So we are encouraging parents to learn too, along with their kids, aren't we? Remind yourself what a ratio is. Yeah, absolutely. Absolutely. So I'm being stretched, my kids being stretched, my teachers being stretched, my district academic specialist is being stretched. We're all being stretched right now, right? But we're all learning. And kids are telling me more about this now than they ever told me before when I told them, by the way, guys, this is a ratio and there's 3 ways to write it. We can write it like this. We can write it like this. Or we can write it like this. And now you understand all there is to know about a ratio, right? Go home and build a table, please. And if you don't know how to do it, just ask your parents to do it for you. I know, because we never learned it that way. But I'm telling you, because I've been in those classrooms, and I've been teaching these lessons, and I've been talking to those kids, and I've been asking them questions. And the kid that can tell me 12 times 12 is 144, and I say, show me the double-double way to do that, they can do it. They can do it. Oh, you guys are opening a can of worms, right? I'm not going to do 12 times 12, okay? Just this is what we call an array. This is another way to look at multiplication. This is an area model. For those of you who know how to do area, right? Here I have 4 units. Here I have 5 units. To figure out the area of this, I multiply 4 times 5, right? And I get 20 units, right? 4 times 5 is 20. All right. The double-double method is a way of taking this array and breaking it into 2 smaller pieces of the same size. So now I can look at this one, and this is 2 times 5, and this is 2 times 5. I know that this is 10 and this is 10, and together they're giving me 20. Okay? For this problem, probably not all that important. But for some of those bigger problems, for some kids who are not visualizing 12 times 12 really well, they've suddenly got an end to the problem. Exactly, thank you. She says it's using different parts of your brain, which is why it's so important to be showing different ways for these kids to solve problems, because I was the analytical, mathematical, linear thinker. 12 times 12 made sense to me. But I had 3 friends who had no clue how I could do that stuff in my head. But as soon as I would do something like this and say, well, this is what you need to see, they would go, oh, that's easy. Because they use the other side of their brain to solve problems. But if I didn't show them that, they would never get the opportunity to know that they could do math just as well as I could. They just do it differently. It's okay to do it differently. You don't have to do it my way. It's okay to understand what you're doing. It's okay for everybody to be smart and do it a different way. I can't tell you how good it is for me to go in and teach a lesson and to tell the kids, I'm sorry, that's all we have time for, and have them go, no, we want to do more. They never did that before. It was like, okay, cool, books are going in the desk, recess? You know, it's very exciting. What's exciting to me too is that I can go into a class and I can say to kids, I want you to solve this problem for me. I don't want you to talk to anybody. I want you to solve the problem your way. Just solve it. I don't care how you do it. Okay? And I'm going to walk around the room and I'm going to see and then they're going to count them, right? Or they're going to tell me 6, 12, 18, 24. I know what the answer is. Okay? One of them's going to go, okay? Do you see what I'm saying? But I have every single kid doing something. Before, if I had just put this up and told him, give me the answer, I'd have 5 kids working, 5 kids banging pencils, one poking his neighbor, one trying to climb under the desk so I wouldn't know he was there because they didn't know what to do with it. They didn't know how to begin. I am pleading for all of our kids and their wonderful minds that I love as much as you guys do. Let's let them really understand what they're doing. Let's not limit them to this and say, if you can't do that, I'm sorry, you just can't do math. And they've been hearing that. Well, if I can't do that, I can't do math. I can't do that. I'm not a math person. It breaks my heart. Every single child is a math person. If you watch kids that play naturally, they play mathematically. Every kid is a math person. We take that out of them. Number 3. So the area of a rectangle is 280, and one dimension is 14. What is the other dimension? Okay, now remember, we're not jumping to 280 from 3 times 2, right? We have been building an understanding by building some ideas like the double-double, ratios, area models. By the way, the kids tell me, I say, I want you to multiply something, and they'll say, do you want us to use an array? Do you want us to use, I mean, it's, oh, okay, whatever you want. But they will ask that. How do you want us to do it? How cool is that? How many kids have ever in the past said, how do you want us to do it? I've heard a lot of, I don't get it. What am I supposed to do? What? No, the question is, how do you want me to do it? I can do it 2 different ways. Which one do you want me to do? How awesome is that? So I would make sure they have this because some kids are going to need this, right? They're going to need to draw it. And probably not draw 280, but they're going to figure out a way to make it fit on that sheet and to represent what they want it to represent. They're going to create groups. A lot of them are going to notice there is a 0 on the end of this number. And then what they're going to say is, oh, I can work with 28, and then I know I just need 10 of those. So whatever I get with 28, I just put 10 of them together, and I got it. That is really cool. It's not now when you multiply by 10, you just put a 0 on the end of it. Why? You just do. Just do it. It just works. How many of you knew why you put a 0 on the end of a number when you multiply it by 10, right? Right. 2 hands out there, right? Why is what's important? Why is that 0 work? Because it means 10. And it means you've got 10 of whatever you're building. And kids know that. They know that. And they know that they can break it up and make it 10 smaller and work with a smaller piece and then put it back together at the end and get the right answer because they understand that the numbers relate and there's a reason for it. That's why Common Core is so important. And that's why I will defend it till my dying day. Because I want every one of those little kids to tell me, I know that there's 10 more of those. I know that. You are going to have access to this. I have created a resource sheet for you. They have promised me they have all your emails. This is a Google Doc. And you guys will be able to use this right here on the Bridges free apps for mathematics. Those are apps offered by Bridges, and that's the link to the site. These are downloadable apps for iPads, or you can use them in browsers if you don't use an iPad. The Rec and Rec is there. They can manipulate online with their apps. All kinds of cool stuff there that they are using in class to solve problems that if you have computer access at home, they can use those same things at home to solve their problems. All right? This is a site that just has lots of the National PTA site, resources in English and Spanish, all about Common Core, why math is being taught the way it's taught, just some really, really neat stuff there. The K-8 Common Core Parent Handbook, that one unfortunately is only in English, but it is really good information about Common Core math from K to 8. Bridges Math Program. This is all about Bridges. You can go there, look. There are some videos on these sites. You can watch teachers in the classroom and what kids are doing. Okay? Strongly recommend you go there. Talk math with your kids. Christopher Danielson is a friend of mine, so I'm giving him a little plug here. He is a math professor in Missouri. His research is based on how kids think and learn. And he has started a website for parents to help you understand how to help your kids by talking math in just normal everyday situations. Okay? And he's actually, I was just on there the other day, and this is new. He is now broken it up by grade level. So you can go in there, and you've got a 4th grader at home, you can go look at how he's having 4th graders talk about math and what parents are doing there. And you can also post there too. Okay? And then this last one is all about the CASP, because now we're doing interims at the 3-5 level. And again, we're going to do the summative at the end of the year. There are parent resources there in English and Spanish. It tells you about what the interim is, about what the summative is, about how they're being used. It talks about block assessments there, which we are not using at this time, but there are a couple of sites out there, Browns Valley being one of them, where they are starting to look at those block assessments and think about how they could use those to help their kids be ready for the interims and the summative exams by seeing other tests of the same type. Okay? Great, great information there. That link takes you right to the page where all the really important information for parents is.